Hi everyone, this is Mrs. Pagan, and in today's lesson we're going to be talking about linear inequalities in two variables. We're going to graph these and check to see if some of these points are their solutions. Alright, we're going to start off a little bit easy. Some of the examples are just going to ask you check whether the given ordered pairs is a solution of an inequality. And what we have to do is kind of just check and make sure if it works or not. So if this is our inequality, 2x plus 3y is greater than or equal to 5, then what we have to do is take our x is 0 and y is 1 and substitute them into our inequality. So we have 2 times 0, because x is 0 again, plus 3 times 1, because y is 1, is greater than or equal to 5. Well, let's see if that's true. 3 times 0 is 0, plus 3 is greater than or equal to 5. Is 3 greater than or equal to 5? And the answer to that is no. Therefore, we can make the following statement. 1 is not a solution. So if we say, no, this is not a true statement, then, the obvious answer is no, it does not work. Therefore, no, it's not a solution. Alright, let's try another one. Let's do 4, negative 1. So we're going to go ahead and take this inequality again. 2x plus 3y is greater than or equal to 5. And we're going to substitute in our x for 4 and negative 1 for y. So here it goes. 2 times 4 plus 3 times negative 1. Is that greater than or equal to 5? Well, we have 2 times 4 is 8 plus negative 3. Is that greater than or equal to 5? Well, we have 5 is greater than or equal to 5. Since 5 is greater than or equal to 5, we know, yes, this is a true statement. Therefore, we can say the following. 4 comma negative 1 is a solution. Yes, it works. Yes, it's awesome. Yes, it's a solution. So that's our final answer. Alright, I want you to go ahead and try C. Pause me really quick, try it out, see how it goes, and we'll look at the answer in just a second. Just kidding, in class. Alright, let's keep moving. Alright, we're going to be graphing inequalities by following general steps. And the steps are pretty much graph the boundary, which is the inequality, and we're going to determine if it's solid or dashed, and let's kind of talk about that now. If you have a solid line, that means that the line is part of the answer, so it would have to be things like greater than or equal to, less than or equal to. The equal to part makes it solid. And if it's dashed, then we have things like less than, greater than. These obviously do not include the line, therefore it is dashed. So keep that in mind. We're going to test a point in one region. Actually, that's why we did these examples up top, to kind of practice the testing a point in one region. And we're going to go ahead and shade the region, because when it's an inequality, we're talking about a section of answers, not just one answer. So keep that in mind. Alright, let's kind of start off with some of these graphs. First of all, it says graph the linear inequalities in one or two variables. So this is in one variable because we only have y. So what I'm going to do is graph this as if it's y equals negative 2. So I'm going to go to y is negative 2 here. And I'm going to ask myself this symbol, would that be a solid or a dashed line? And that is a dashed line because the negative 2 is not part of the answer. So here's what we do. Draw a dashed line. And it's a horizontal line because it's a y equals negative 2 line. And then what we do is test a point. I'm going to do the testing underneath. So the easiest point is a point that you can kind of do in your head. I like to use 0, 0 if the line does not go through it. So 0, 0 is my testing point. I want to know, kind of like above. And we know x is 0 and y is 0, so here's the equation. 0 is less than negative 2. Well, we don't have an x, so there's nowhere to put that, but we have a y, so 0. 0 is less than negative 2. Well, 0 is not less than negative 2, so that's not true. That means the following. 0, 0 is not a solution. Now, if 0, 0 is not a solution, that means that everything on that side is not a solution. So what I do is I jump ships, I go to the other side of the line then, and I say, okay, well then the other side has to be all the solutions, okay? So there are two sides to this line. One is kind of this section right here, all this above, and the other one is all this stuff below the line. So if the above part doesn't work, then you got to jump to the other side of the line, and that's ends up being our solution section. All right, which is makes sense. You know, if one is not the answer, then the other side's got to work. All right, let's go into the second one. We have graph x is greater than or equal to 1. So first I'm going to go ahead and circle that. I know that it's going to be a solid line because of the equal to part. And I'm going to go to x is 1. So here it is. And I'm going to draw my vertical line. Now you can see this green x is greater than or equal to line actually created two sides, the right side of that line and then the left side of that line. And now we're going to go ahead and test a point. Like I said, I like to test 0, 0 if I'm not touching it with my line. If I'm not touching that point, you know, why not use it? Well, we have x is greater than or equal to 1. That's our equation. X is 0, y is 0, but we don't have a y, so we don't have to worry about that. 0 is greater than or equal to 1. Is 0 greater than or equal to 1? No. That means that 0, 0 is not a solution, which means that nothing on that side is a solution. So we need to go to the right side of the green line, and that will be our solution area right here. Keeps going further too, but you just can't see it. There it is. All of that is our solution. Alright, let's go ahead and do a couple more. So let's see. Now C, we have a line, so I'm going to kind of graph this as I would, where my slope is -3 and my B is equal to -5, which means I'm at 0, -5. Okay, and before I leave the equation, I also want to notice that it's greater than, which means that it will be a dashed line. Once I figure out where the line is going to be, I'm going to make sure I make a dashed one. Alright, so we're going to start at 0, -5. So 0, -1, -2, -3, -4, -5. And we're going to use our slope -3 over 1. So it's going to go down 3 over 1. Now, I don't have space here, but I'll do 1 that way. Down 3 over 1. And then I'm also going to go up 3 and over 1 to the left. Okay? So up 3 and over 1 to the left, up 3 over 1 to the left. And here's our dashed line. Alright, then we're going to go ahead and start doing our, hold on, let's change colors. We're going to test our point, okay, and the testing point could be anywhere that you want, so let's kind of test the point here. We'll test 0, 0 once again, and I like to put it where I'm testing. And the inequality that we have is y is greater than -3x minus 5. Well, x is 0 and y is 0, so we end up going into 0 is greater than -3 times 0 minus 5. Is 0 greater than -5? And the answer to that is yes. That means that this point is a solution, which means every point on that side is a solution. So that means we will be shading that section, the solution section. So since 0, 0 is a solution, everything on that side will work as well. If it was not, we would go to the other side of the line, right? Alright, let's look at this second one, D. This is the last problem we'll do. I'm going to kind of move it to the side here. Alright. There's a lot to be done here, so let's kind of start with the inequality. Solid or dash? What are you thinking, Joe? Yep, you got it. Dashed. Ooh, I just moved it. Sorry about that. I had a technical difficulty, but we're back. So that's going to be dashed. And then we're going to go ahead and take this inequality, 2y minus 3x is less than 6, and we're going to solve for y, which we have done before. We're going to add 3 6 to both sides. We get 2y is less than 3x plus 6, and we're going to divide by 2. Now, I thought about, do I have to flip the sign for a second, but realize I'm not dividing by a negative value, so the sign will stay the same. And we have 6 divided by 2 is 3. So here's our inequality. And once again, I'm going to go ahead and circle that this will result in a dashed line because it's not equal to, it's just less than. Alright, we're going to start graphing the line. So let's start at 3. 1, 2, 3. Here's the point. And we're going to use our slope. Up 3 over 2 to the right. Positive 3, positive 2. Alright. And here's our dashed line. Alright, we're going to once again test the point. Like I said, I like to test 0, 0 if we're not using it. So testing point, sometimes I even write testing point so I remember. And 0, 0 is our value. X is 0 and y is 0. And our inequality is 2y is minus 3x is less than 6. I like to use the original just in case I'm in an error somewhere here. And then we have 2 times 0 minus 3 times 0 is less than 6. Well, the left side ends up becoming 0, and 0 is that less than 6, and the answer to that is yes. So that means that 0, 0 is a solution, which is awesome, because that means everything on this side will become a solution. So we are going to shade that side of 0, 0. So everything on that side is now a solution. Alright, well, I think you guys did an excellent job today, so give yourself an applause, and I'm excited to see you in class, so kind of be ready to answer some of these questions, okay? We'll work on the last 2 problems in class, so everything is okay with the video. Have a great day. Bye.